Okay, the next time-consuming thing worth mentioning on these builds is creating your cable harnesses. I just spent a couple days crimping. There is a lot going on in the wings of this aircraft. So let me just summarize what I have here, what you're looking at. So this is a cable harness that would go from the wing joint to where the power box or receiver is, with all the connectors there. And I had to split this. I have the two servos, aileron and flap, and then the landing gear and brake, they have to have their own two connectors because they're reverse polarity, or the landing gear does. Then this one will be for all the LEDs. There was not much opportunity to reduce things like here on the servo. Notice I have the negative wires together because on most power box type systems like Spectrum's Power Safe, they have one negative bus on all the servos, so you can combine all those and use one pin. On the LEDs, it would be the positive pin. Most LED controllers have a pull-up resistor, so the red wires could be connected together, but it wouldn't have saved me much here in terms of pins, so I decided to go this way, where each LED has its own connector or set of pins. So we have nav lights, we have strobe, we have landing lights, we have two servos, landing gear, up and down, and wheel brake. So a lot going on in the wing. I am a big fan, by the way, of these white connectors. I buy these on a kit like this in Amazon for $12, and these are automotive. These are awesome. You can crimp here 22 gauge servo wire that I use, and it's got a large surface area. This carries several amps easily, and I love these things. I've used it on many aircraft now. There are different sizes. The largest one is this 3x3, so 9 pins, but they're smaller, and you can see you get a whole box for $12. Much better than buying, pre-made Ashlock or whatever they're called and all of that. On the wing side is the male side, and as you see, I have all this ready to go. The gear and the brake will plug in here, servos, and all my LEDs, and then this is what I'll connect each time when I put the wings on. For the rear of the aircraft, where I have two elevators and a rudder, I'm running this in a thermally protective sheet. That's even in the instructions, and then this connects to the power safe receiver. So these take a long time, a lot of crimping, but once you do it, you have a nice custom cable harness system. All right, so let's keep building. Off to part 2. So we're working on the wing here, and it's coming together. I just wanted to show everyone how I align my servos for the flaps, for example. So I'm using my trusty Spectrum tester, and I put the signal at exactly the center. So this is when the servo centers, and that's when I have the flap aligned beautifully. This is basically the flap up position. And then on the way, when the signal is in the opposite direction, that's the most deflection I'll get, which is plenty. I just measured that that's more travel than we need. So I like to have, then I get, with this kind of a setup, I get the least buzzing. It's buzzing a little bit right now, but when I turn it upside down and the weight's the other way, it stops buzzing. So that's how I do that. And then for the aileron also, center will be, where it's all beautifully lined up with the trailing edge of the wing. So I ran into some issues with the aileron, actually very similar to the ones I had on the MiG-29. So let me show you here the angles. So this horn is at the wrong angle. And, I glued it in using the slot that was pre-cut, but it should actually be a little bit more in this direction. And what that does is if you create the servo horn connector, if you would, using the stock equipment, there is not much movement here in how much the angles is allowed between the connector and the push rod. So I had to create my own. I happen to have these pieces here that I bought on Amazon, and as you see, they allow for a much wider angle, and I'm using those here. And in addition to that, I had to cut this same thing. I had an issue on the MiG as well, because in the furthest deployment position there, this binds up here against the wood. So you have to cut a slot, and then the cover that goes over this will have to have a little cut as well, right there. But anyway, it works okay, and I'm getting, very well actually. I'm getting full deployment, about 30 millimeters in each direction, so way more than called for in the book. But again, I needed this connector to have a lot more freedom of movement here and down there as well, to compensate for the angle mismatch. I don't know if this is a BlackHorse thing, because same thing happened on my MiG. I had to redesign this push rod, but once you do that, everything will work great. So this will be awesome. And again, when the servo is centered, I have these control surfaces. When both the flap and the aileron servo is centered with my servo tester, I have them, nice and level. This way, I have to do very little sub trim in the transmitter. That's what I'm doing about the lights on my Viper. So the Viper has a real opportunity to do some interesting things with it, because it has, I'm going to show the wing here. It has this indentation, I taped it up, where you can put up to 3 basically reflecting headlamps there. In my case, it's going to be a strobe and a landing light. Some people put the green or red navigation light here because it's easy. You have the holes already here. I decided to do something else, and mine will look like this. One moment. And as you see, it's on the very edge there of the wingtip. And so how did I do this? I kind of like how this turned out. So here's what I did. I am using these lenses because they're extremely inexpensive, from Motion RC, from the Freewing F14, and it has these cool curved lenses. And so then all you have to do is drill a hole in there and put the lens over here and just basically CA it right there. And there is already a hole back here. And I don't know if you can see that there. And you can put the LED in. Now the lights I'm using are Unilight, but I want to make a comment about Unilights. I think they're extremely overpriced. They're basically, Chinese LED chips. And the main intellectual property that Unilight has is the cooling. So, they have a heat sink back here, but it's the same chip. And here is the reflector one I'm going to use. They're all very, very expensive. And then if you add the controller to it and all of that, it's way over $200 for an aeroplane. So here's what I'm doing. I'm still using the Unilights, but I bought on Motion RC the GT Power. It's a 3-watt kit for $34 that includes a light controller and a bunch of LEDs. They just have these kind of unfortunate heat sinks that, work great on behind a larger surface. Like here is a white one, and they have colored ones as well. And basically, what makes an LED a 3 watt or a 4 watt is the heat sink, so it can withstand cool itself off the temperature. So what I'm doing is using the 3 watt controller. I bought the Unilights, are 3 watt to 4 watt. And what's great about it is you don't actually need the resistors that come with these. Let me show you one here. So these, for example, the reflector lights, this white one, they're designed to be actually plugged into a 2S power source. So, a 8.4 volts, instead of this big resistor here. This controller has the resistor and all the voltage, everything taken care of inside. So I removed it here and put some heat shrink on, and I'll show you how this works. I did leave the resistor on the nav light. It makes it a little dimmer, but I've noticed it was heating up quite a bit without the resistor, and those stay on all the time throughout the flight, through taxi time and all this. I don't want them to get too hot and shut off. So I did put the resistor back on. That came with it. It's bright, plenty of bright enough. So let me show you how this works. I'm going to connect this controller to a light source. Here's my Unilight being controlled by the GT power controller, stays on the whole time. And here is a nice strobe. I'm not going to point it, but here is a nice strobe without the resistor. And this one won't heat up because the duty cycle is so low. There's not enough power to heat it up. If it was constantly on, that'd be different. So recommend this system. Saved myself a lot of money.